Well, good afternoon, everyone, and welcome to today's live astronomy show from the Science Museum of Virginia. My name is Justin. I'm one of the astronomers here at the museum, and I'm happy to be your guide today. If you've watched some of our previous episodes, welcome back. If you're watching for the first time, if you like what you see today, we've got a couple dozen previous shows archived right here on Facebook. Head up to the video link, or you can watch them on YouTube as well. And as always, I want to thank our sponsors, Allianz Partners, for being with us as well. A couple of notes before we get started. We're going to be using software that is similar to what we use in the dome here at the museum. It's planetarium software called Digistar 7, and it can do some pretty cool stuff. So I recommend watching the video full screen if you can. If you're on a computer with a nice big monitor, you'll see some pretty cool stuff. I think we should actually switch over to the software so you can see what it can do. So let me set up our first segment of the day, and I'm actually going to show you kind of what my view of Digistar usually is. You come into the dome at the museum, and it's a big curved screen, wraps all the way around you, but the content we make for the dome still has to happen on a regular computer. So I see it in a round circle like this most of the time. But this is how we visualize the sky, or whatever we're flying through in the planetarium. And I'm starting here because of some important events that are coming up in the not too distant future. If you look at your calendar, like the one I've got right there, on Monday, you may see that it is the solstice, the winter solstice for us here in the northern hemisphere. Now, what does that mean? Well, the solstice is one of the extremes that we experience here on Earth, thanks to the way we exist in the universe. It's a way to kind of see our connection to the universe. So let me show you what's going on. First, let's rewind the clock. Let's turn the calendar back 6 months. You'll have to imagine it. Let's see what the sun did on a day in late June. So it rises kind of far in the north, travels pretty high in the sky. That's what the middle of that circle is the point directly overhead, and then it sets pretty far north in the west as well. All right, interesting. Well, let's pull the calendar pages forward another 3 months, September. In September, the sun on the equinox rises basically directly due east, sets directly due west. That spends almost exactly 12 hours in the sky during the day. So that's why we call it equinox. What's going to happen on Monday? Well, on the winter solstice, the sun rises fairly far towards the south. I mean, it's still in the eastern part of the sky, but it rises in the southeast. It sets in the southwest. It doesn't climb as high in the sky at midday, and doesn't spend as much time in the sky during the day. If you're keeping track, on Monday, we should get about 9.5 hours of daylight. The rest of the day, darkness. But the good news is this is the shortest period of daylight that we see during the year. So from here on out, it's longer periods of daylight until we get to the next summer solstice. So that's the way it's going to look in the sky. But we're here today to fly around in space. So let's take a look at how this looks from up above. So let's leave the Earth behind here. We'll get into space, and to really explain it, we've got to get into some technical bits of information that usually don't focus on during these shows too much. But I've got our coordinate system that we use here on the Earth, latitude and longitude. We've got the equator that goes 0 degrees latitude. We've got the poles, the North and South Pole. All I did was stretch those coordinates out across the sky, and that gives us the celestial coordinate system. So there's a celestial equator that is just like a copy of the Earth's equator stretched all the way across the sky. There are celestial poles that are stationed directly above Earth's poles. So if I rotate us around here, you can't see the poles anymore, but you've got to imagine that Earth's North Pole points right to the center of that little triangle up above the planet. So if you can understand the latitude and longitude system here on Earth, the coordinate systems we use in the sky should make some sense to you. Astronomers, of course, use different names for their coordinates, but it's exactly the same idea. But there's something I haven't shown you yet. It's the orbit of the Earth around the sun. And if I bring that into view here a little bit, I'm going to back away from the Earth also so that we aren't in the line that is used to trace the orbit. You'll see that the orbit, well, it isn't really lined up with that celestial equator. It's not pointed towards the celestial poles or anything like that. The Earth is tilted a little bit compared to the plane of our orbit around the sun. If I zoom back in on the Earth, you can kind of get a sense of where the plane of our orbit is because, well, one side of the Earth points directly towards the sun, the other side of the Earth points away from the sun. So one side is in daylight, the other is in nighttime. And this should be more or less right now. Let me fast forward here to the solstice on Monday. So you can see that comparing the day and night line, which is related to the plane of our orbit around the sun, and the coordinate systems that we use, the North Pole is completely dark on the solstice. If we rotate around to the South Pole, it's in daylight, and you can kind of hopefully intuitively see that well, in the southern hemisphere they're actually going to get more sunlight on Monday than those of us living in the northern hemisphere will get, so that the seasons are reversed on opposite hemispheres. And well, that pattern should hold up if we look at different times of the year. So this is Monday, the northern hemisphere pointed away from the sun. Now I'm going to lock us into the Earth. So the Earth will appear stationary compared to the stars. Yeah, that's kind of how humans thought it worked for thousands of years, but we figured it out a few hundred years ago. We are moving around the sun, but it's going to look on your screen like things are moving around us. So sun now on the other side, but notice the poles of the Earth still point exactly the same way. So when we get to the other side of the solar system, seasons are reversed. So this is actually looking forward to our next summer solstice. Check out an equinox since we're here. And now to really see what's happening, rotate around just a little bit. So now the day-night terminator, the line separates daytime from nighttime, nicely lined up with the poles in both hemispheres. So there you go. Quick little run through of the seasons as they appear in outer space. Just for fun, let's put all of the seasons up there together, or all these special days on our screen together here. So we've got the winter solstice and the summer solstice, and we've got the two equinoxes. I'm going to put giant copies of the Earth on the screen for you to highlight the way those appear from space all together. And the one closest to us, that's what we're going to experience on Monday. That is the winter solstice. So get ready for the shortest time that the sun will be in the sky all year. Now, if you happen to miss that, luckily there's something else on Monday that you can watch in the nighttime sky as well. So let's take a look at it. First thing I want to do to highlight that is get us back to the present day. So a quick jump there. And then I'm going to try and line up the orbits of the planets. So let's see how close I can get them here on the screen for you. So we've got 8 major planets. They've all got slightly different paths around the sun. And man, no matter what I do, they don't quite line up with each other. But that's just because the orbits of all the planets are on slightly different planes. So we've got our orbit around the sun, but all the other planets have slightly different orbital planes. They aren't perfectly aligned. They'll stay pretty close to each other as we look out across the solar system. But on Monday, we've got an opportunity to see 2 of the planets more closely aligned than usual. So I've gotten rid of some of the extra stuff in the solar system. Just got the Earth in its orbit around the sun there, and I've left Jupiter and Saturn on there too. Now, I couldn't get all 3 of these orbits perfectly aligned if I tried, but if we look at a moment in time, sometimes the planets are nicely positioned so that they are very closely aligned with each other. If we get a little closer to the Earth here, you can see that little dots representing Jupiter and Saturn are very close together. I can almost make them turn into one dot on the screen if I choose just the right angle to look at. And if we get more of a bird's eye view here, I can also add a little bit of a line here to help you see what's going on there. There is almost a straight path that we can draw from the Earth to Saturn straight through Jupiter. Now, this is a little bit unusual. Jupiter and Saturn get lined up on the same side of the sun, every 20 years or so. But when they line up, sometimes Jupiter will be well above Saturn or well below Saturn. But this time, they're going to be closer together than they have been in a long time. So if you head outside after sunset tonight, look towards the southwest, low in the horizon, say around 6 o'clock. I think there might actually be clouds tonight, but if it does clear up, you'll be able to see those two planets are pretty close together. If you check again through the weekend, they'll get a little bit closer, and then on Monday, they'll almost merge into one object, as we will see them here. They'll make their closest approach during the early afternoon here in Richmond, so we'll miss the very closest approach, but they're moving pretty slow, so they should still look pretty close in the evening. In fact, this is what they will look like from here in Richmond about 6 o'clock on Monday evening. Again, weather permitting, I can't account for the clouds. As you can see them just with your own eyes, it should serve as something of an eye test for you. Everybody's eyesight is a little bit different. You may be able to see a little bit of space between the two planets. They may look like they have merged into one object. If you've got some decent binoculars, definitely point them that way. You'll see a really bright double star, essentially, a double planet through your binoculars. If you happen to have a little telescope, that's an even better view. There, you should be able to see the two planets in the same telescopic field of view. The moons here, I'm depicting them where they will actually be. Your mileage may vary depending on your telescope's optics. You may not be able to see all of those moons, but that's where these worlds will be positioned on Monday night. Now, if clouds happen to get in the way on Monday, or you just forget to look outside, Sunday, still a pretty good show. Tuesday, still a pretty good show. Closest together on Monday. If you happen to miss it all week, the next time they will be this close in the sky is the year 2080. So eat healthy, get some exercise, get your vaccines, maybe see them in 2080. After that, well, it's kind of a long wait. When was the last time anybody was able to see the planets this close together in the sky? Well, for that, we've actually got to wind the clock back all the way to, June or July 1623. Almost 400 years. Now, we actually don't have any written records of astronomers observing this conjunction in 1623. People were observing the sky pretty closely. The telescopes had been around for a little over a decade at this point. So almost every time astronomers pointed a telescope at the sky, they saw something brand new. The problem with the one in 1623 is it happened pretty close to the sun. So it just wasn't convenient. Maybe nobody actually looked at it. So when was the last chance that humans had a chance to see these two planets so close together? Again, it's a jump of almost 400 years. And this one was for the early birds, about 4 in the morning on March 4th, 1226. The two planets arose actually even closer together than they're going to be on Monday. Nobody had telescopes back then to look at it, so they would have just seen a single brilliantly bright planet with actually Venus not too far away. So it would have been a pretty good sight. Since I'm going to zoom in as if they had a telescope back in those days and see those two planets pretty close together once again. All right, looks like a question has come in. Let's see. Sarah asks, which direction should you look in? Well, they'll be following the sun low in the sky in the southwest, just after sunset tonight. The original screen I was showing you was, again, about 6 p.m. If you're out a little bit later, they'll be a little bit lower, a little closer to the horizon. The sky will be darker. That's good, but it'll be a little tougher to see. So southwestern sky, just after the sun sets tonight, or tomorrow night, next night, Monday, same part of the sky, about the same time. Thank you for the question, Sarah. All right, well, two great things to look for on Monday. The solstice, not that much sunlight. But then once the sun sets, the real show begins, this so-called great conjunction of Jupiter and Saturn. Weather permitting, hope we get to see that. But we've got a little more time left. Let's look a little farther into the future. Monday will be a good day. Then we've got, a little over a week left in the year. You can look forward to some videos we're putting out from the museum in the coming days, looking back at the science that occurred in 2020. Got one about the highlights in space from 2020 as well. But one of my favorite things to do is really to look forward into the future. And we're going to go beyond Monday here. let's look into the year 2021. And that means it's a perfect time for one of my favorite bits, one of the old staples from our live shows in the evenings. Let's talk about whether things will happen. That's right, ladies and gentlemen, it's time for Will It Happen? The idea is pretty simple. I put a statement up on the screen and I tell you why it may or may not happen in the coming year. For example, if I said, oh, there will be 2 major observatories, brand new telescopes that are brought online in 2021. Is it going to happen? Well, I sure hope so. And here are the names I am going to be watching. First, the Vera C. Rubin Observatory. It's currently under construction in Chile, but it's nearing completion. And although they were slowed down a little bit by the COVID-19 pandemic, construction is going pretty well. Telescopes should get installed in the not too distant future. And right now on their calendar, they're targeting their first light for late 2021. Now, first light is kind of a big deal for a telescope. It's the first time it is used to take a picture of an object in the sky, and it's the chance for scientists to see how the telescope and the instruments behave, get them calibrated, and get prepared for new groundbreaking science. Now, for the Vera C. Rubin Observatory, the science really is going to be groundbreaking. The telescope, it's not going to be the largest in the world, but it will have the largest digital camera in the world installed. What that will allow it to do is survey the entire sky. Over the course of about 3 nights, it'll map the entire sky visible from its location in Chile. And once it photographs the entire sky, it'll start over again. And this is scheduled to continue for 10 years. So essentially what we get from the Vera C. Rubin Observatory is the largest time-lapse movie ever made. We're going to have a high rate of imagery of everything in the sky, or at least most of the sky, what's visible from Chile here. What will that allow us to do? Well, we could find millions, if not billions, of new objects, countless asteroids, comets, interstellar visitors here in our solar system, witness supernova explosions, find unique kinds of variable stars. The list goes on and on. Kind of the amazing thing here is that it's not just astronomy that is going to be revolutionized by this. A lot of other disciplines have had to contribute to this project. Every night that the Vera C. Rubin Observatory is operational, it'll collect about 20 terabytes of data. That is the equivalent to streaming about 9 months of Netflix. It's over 6,500 hours. So they're collecting that amount of data every night. You can do the math for how much they will collect over 10 years, and that has to be stored and analyzed to make all these discoveries. A pretty amazing feat. Another amazing feat is scheduled to take place in 2021. This one's been featured a few times in previous Will It Happen episodes. The James Webb Space Telescope is scheduled to launch again in 2021. Now, it's had several scheduled launch dates, but delays in the project have pushed it back. But I was just reading today that they've completed another major milestone. This big sunshade that will shield the telescope optics from the sun's light was totally unfolded, stretched to the size and tension it'll be in space for the first time, making sure all those pieces work correctly. Now they've got to start a 2-month process of folding it back up to actually get it packed on top of the rocket. But if everything goes well, this telescope will launch on Halloween, October 31st, 2021. It takes a little while to get out to its position. It's here about a million miles from the Earth, and they'll begin its own groundbreaking survey of the solar system and the universe beyond. One of the big goals here is to actually directly observe light emitted by the very first stars to form very early on in the universe. So another pretty amazing project to keep an eye on. So there you go, 2 new major observatories, the Vera C. Rubin Observatory and the James Webb Space Telescope. Keep an eye on those. What else might happen in 2021? Well, how about Venus? Maybe Venus will get some extra attention. it's a planet that maybe you don't hear a whole lot about. It certainly made a splash in 2020 with the announcement of the discovery of a gas called phosphine in its atmosphere. Now, there's still some debate about that, but certainly get at least a little bit more attention on Venus here, because this spacecraft is going to fly by, and there's some hope that some of its instruments will be able to unravel a little bit of this mystery around this detection of phosphine. Now, it's exciting because the phosphine gas could be due to, maybe life in the atmosphere of Venus. Pretty strange. So when this spacecraft, Bepi-Colombo, flies by in August, I'll certainly be studying what they can. This is not the spacecraft's final destination. Bepi-Colombo is on the way to Mercury. It's just using some gravity assists from Venus to get into the right orbit. But maybe it'll be able to shed some light on that ongoing mystery. And there's another reason we may hear a little more about Venus next year. NASA is always looking at what missions they should launch next. And early this year, they announced finalists for one of their programs where they selected 4 spacecraft that may launch to different targets across the solar system. And Venus would actually be targeted by 2 of these spacecraft. So 50% of the finalists, 2 out of 4, would target Venus. So pretty good odds that NASA will select a new mission, in this case either Veritas or Da Vinci Plus, to fly to Venus. Each would do its own separate mission there. One of them is an atmospheric probe, though, that may get bumped to the top of the list because of this debate about phosphine in the atmosphere. So keep an eye on Venus in 2021 as well. Well, that's probably not the only planet we should watch. In 2021, we get 3 arrivals at Mars. Well, spacecraft arrivals is what I mean there, and I can definitely guarantee that 3 spacecraft will get into the neighborhood of Mars for the first time. If you followed any of the episodes this year, you know that 3 spacecraft are on the way to Mars, all launched back in July, and they're all scheduled to arrive in Mars's neighborhood in February. Now, each has to do something different to successfully stay at Mars and start their scientific missions. The first 2 have to fire their engines to enter orbit around the red planet. NASA's Perseverance rover has to successfully enter the atmosphere and land on the surface. Now, if they are successful, they'll join a long history of Mars exploration. This little map here is something I like to use to kind of visualize how we have explored Mars in the past. So all of our icons are on the other side, so let's do a quick orbit here. I've drawn a bunch of circles around Mars. Each one represents a different spacecraft that was sent towards this planet. They're color-coded by the country that launched the spacecraft, and then they've got little icons, if I get a little bit closer here for you, that show you what the mission was supposed to do. Certainly not going to describe each one because there are over 50 different spacecraft represented here. Each one had its own chance to get to Mars and do its prescribed mission. Not all were successful. If you notice that some of these circles were dashed there, that represents missions that didn't go as originally planned, and a lot of them did fail in one way or another. We've gotten a little bit better in recent years, but it's certainly no guarantee that the mission will be successful until it gets there. It's either done its entry, descent, and landing, or fired its engine to go into orbit. So the big question is how those 3 brand new spacecraft will fare in February, and all we can do is wait to see how it goes. In the meantime, a couple more things to keep an eye on in 2021. How about some new crewed spacecraft? We've got a robot flying by Venus, perhaps new robots getting a chance to fly to Venus. We've got robots potentially flying or arriving at Mars. How about humans? What are they going to be up to? Well, there are a few contenders for new crewed spacecraft that may take flight in 2021, but I want to preview specifically NASA's Commercial Crew Program. In 2020, SpaceX's Crew Dragon spacecraft carried astronauts into space twice, launching from Kennedy Space Center, the first time astronauts have launched from American soil in about 9 years. Now, the Commercial Crew Program is supposed to have another component. The Boeing Starliner capsule is also scheduled to carry astronauts into space. This capsule has done an uncrewed test. It was about a year ago. There's going to be another uncrewed test in the next few months, And that means by the summer, the spacecraft may be ready to carry astronauts into space. If you want a little bit better look at the Crew Liner or the Starliner spacecraft, I can do that for you here. So there's what it looked like on top of its rocket before its test last December. And hopefully we'll see it carrying astronauts to the space station later on next year. And if it does, this will actually be the first time that the U.S. has had multiple crewed spacecraft operating at the same time, orbital spacecraft. So that'd be kind of a historic thing as well. So keep an eye on that. So hopefully we'll have people headed to the space station on a new spacecraft. Even if Starliner gets delayed, there's another suborbital spacecraft from the company Blue Origin, and China is working on a new crewed spacecraft as well. So humans may be getting a new ride into space, but in the not too distant future, may have new destinations as well. Before long, NASA wants to send astronauts back to the moon. And I certainly talk about missions to asteroids all the time. So one last thing I'd like to propose for 2021 is that our exploration of the moon and asteroids is going to expand. I guess before I give away the video, I should put the Will It Happen graphic up there. And even if you watched the show 2 weeks ago, you heard a little bit about sample return missions and some updates to those missions. The Hayabusa 2 team has opened up their sample return capsule, and they have found bits of asteroid Ryugu inside. And then just on Wednesday, the Chang'e 5 capsule landed in Inner Mongolia, and that surely will have samples inside as well. They've actually got video evidence of that collected on the moon. So we've got the newest lunar samples to return to the Earth, the first ones in over 40 years. Those missions now look to have successfully completed. But what's ahead in 2021? Well, more missions to the moon, more missions to asteroids, and in at least one case, it may happen thanks to the same rocket. NASA's Space Launch System, or SLS, is scheduled to make its first launch in November of 2021. This will be the Artemis 1 mission. So the first launch of NASA's Artemis program would be the first launch in NASA's path to get astronauts back to the moon. Now, no astronauts on this spacecraft. An uncrewed Orion spacecraft will loop around the moon and come home. But then there's extra room on the rocket, so there's supposed to be a dozen different CubeSats, small satellites riding along. Most of them are going to continue on to the moon and study it in some way, but one of them is scheduled to fly off and explore an asteroid of its own. It's the NEA Scout mission, or Near Earth Asteroid Scout mission, and it'll explore its own target. Let's see if we can track it down. So we're going to leave the Earth behind here, and let's get the orbit of the moon up there first, just to give you a sense of scale. Even if the Artemis 1 rocket does not launch, another handful of missions to the moon are scheduled to depart in 2021, and other missions to asteroids as well. So I think I'm pretty safe here. If NEA Scout does get off the ground, its target is a little asteroid called 1991 VG. You'll see it there. And another asteroid I'm highlighting here is called Didymos. Now, it's the target of a separate mission, scheduled to launch in the summer. It's called DART, and DART is part of NASA's ongoing planetary defense programs. This really means protecting us from asteroids that may hit us. Now, Didymos is not going to hit the Earth. We're safe from that, but it does have a little moon named Dimorphos. And what the DART spacecraft is going to do is intentionally crash into the moon to see if it can change the orbit of the moon around the asteroid. Now, what that would tell us is whether it's worth using the so-called kinetic impactor technique to divert an asteroid if we do find one on an impact course with the Earth. The other picture there is the NEA Scout. It's designed to test whether we could use solar sails to inexpensively explore near-Earth asteroids or other targets throughout the solar system. Speaking of other targets throughout the solar system, another spacecraft scheduled for launch in 2021, named Lucy, has a few of them. It's going to fly through the asteroid belt, fly by one asteroid there, and then it will be on an orbit around the sun that will intersect the orbit of Jupiter from time to time. But it's not going to be flying by Jupiter. It's going to target a number of asteroids that share Jupiter's orbit around the sun. These so-called Trojan asteroids are kind of a unique population of objects, and astronomers want to know a bit more about them. So the Lucy spacecraft, if it launches successfully, that's scheduled for October, will make a couple of loops around the sun, a couple of flybys of Earth along the way that will propel it through the main asteroid belt. And then on this elongated elliptical orbit around the sun, it'll make repeated passes through these swarms of Trojan asteroids. There are thousands of them, but 4 of them will be targeted in the late 2020s. One of them we now know has a moon of its own, so it's like 5 objects that the spacecraft will fly by. Then it loops by the Earth again, adjusting its orbit slightly, so it can intercept another object that trails Jupiter in its orbit around the sun, a pair of Trojan asteroids called Patroclus and Menecius. Now, this whole tour takes about 12 years, so it's not until 2033 that it completes. But it should be pretty spectacular. There's not been another spacecraft that's targeted so many objects in one mission, previously unobserved objects. So brand new worlds being revealed to us as long as the launch happens on schedule in 2021. So we've got that to look forward to and so many other things. But before this show lasts all the way until 2021, I should probably wrap up. So again, watch for all those exciting things next year. Watch for the 2020 recap video coming up next week, should be when it is released. And then, of course, on Monday, we've got the solstice, and we've got the great conjunction of Jupiter and Saturn. So much to look forward to, and I hope we're all able to enjoy it together. Because of the holidays, I will have a 3-week break here, so not a 2-week delay until the next show, back on January 8th. Hope to see you then. Until then, keep an eye on the sky on Monday. Have a safe and happy holiday season. I'll see you next year.